to multiply and divide fractions. So to do this, you need to know how to add and subtract fractions. You need to look up your multiplication tables, prime factorization, and divisibility rules. All right, so let's get started. So the easiest thing to do in math is probably multiply fractions. It's a pretty easy concept, just cross the top, cross the bottom. So let's do an example. So let's do 2/3 times 4/5. Okay, so 2 times 4 is 8. 3 times 5 is 15. Okay, this cannot reduce down. So let's have a little bit of how to reduce a lesson. To get 8, that is 2 times 2 times 2. 4 times 2, 4 is broken down into 2 times 2. So 3 2's. 15 is just 3 times 5. They do not share any of the same prime factors. Therefore, it's not reducible. Okay. All right, so let's pick one that can be reduced. All right, so let's do 4/5 times 1/2. So multiply across the top. 4 times 1 is 4. Multiply across the bottom, which is 10. All right, so now I can reduce this. Okay, so they're both divisible by 2. 2 can go into 4. 2 can go into 10. So if I divide 2 into 4, I get a 2. And if I divide 2 into 10, I get a 5. Now that's the long drawn out way to get to the answer. But there is a shortcut. And like I said, time tests, we need to be thinking in shortcuts. So let's look at the shortcut. Instead of doing it this way, hold on a second. When we got to here, we could have reduced before math. Okay? Just get all this out of the way and we'll start all over again. All right, so what we could have done is said these two numbers, the 4 and the 2, can go into one another. And the number that can reduce them is 2. So 2 into 2 is 1, 2 into 4 is 2. Now we multiply. So our new problem looks like this. 5 times 1 over 1. Okay, so now I multiply across the tops. 2 times 1, which is 2, and 5 times 1, which is 5. Look at how much quicker I get to the answer. So this is your goal, to kind of be able to do the reducing um, before the math. Okay. All right, so let's do another one. Okay. All right. All I can see is these two fives. Okay. So to know if they're reduced, they need to be either one on the top, one on the bottom. So either diagonal or top and bottom. So right here I have diagonal fives. 5 divided into 5 is 1, so I can put ones down for each one. And here 3 and 9, 3 goes into each one of those. So that reduces to 1, this reduces to a 3. So I'm left with 1 over 1 and 1/3, which is going to be 1/3. Okay, let's try another one. What if I have something like this? Okay, all right, so 15 and 5 can go into one another. That's 1 and 3. And let's just make sure these can't. So if I do over here on the side, take 2 times 17, we would get 34. So this is 2 and this is 1. 17 can go into 17 one time and into 34 two times. So my answer for this one is also 1/6. Let's do another one. Okay, so what if this time I have, oof, I didn't mean to do that. Something like this. Okay. So the first thing I see is the 14 and the 7, right? So goes in twice into the 7 goes into the 14 and twice and into the 7 once. Okay, so 7 goes into 14 twice and the 7 once. Got a little tongue tied. 3 goes into 6 twice and into 9 3 times. Look, I have two twos, so I can cancel yet again. Cancel that once and that once. 2 into both. So now I have 1 over 1 times 1 over 3, which gives me 1/3. Okay, it's a lot easier if you just cancel before math. It's a lot quicker. And remember, this is a time test. We have to find the quickest route to the end. All right, so right now, let's go ahead and do one. Make sure you get this concept. I'm going to give you guys, well, let's do one together. That's a 3. Okay, so we're going to do a 3. Okay, so here's a 3. All right, first bat, let's start with the left and we'll move our way forward. Is there anything I can cross cancel the 3 with? The 1 we don't care. If we want to reduce everything down to 1s. And I would say, yes, I can do this 15 over here. So 3 can go into 3 once and into 15 3 times. Okay, so now I'm to the 2 over 5 and I want to make those ones. Okay, so I need to find something for the 2 to go in. Well, it can go into 12. So 2 can go into 2 one time and into 12 6 times. All right, now I have this 5. Well, off the bat, I see I have 2 5s. So 5 can go into each one time. Multiply across the tops, I have a 1. Multiply across the bottoms, I have a 6. The answer is 1/6. So let me give you one to do that has a lot of cross canceling. All right, so okay. And let's throw another one in there. Let's throw. All right, go ahead and pause the film. Try this one and then restart it to see if you got it right. All right, 2 goes into 4 2 times and into this 2 one time. Now remember, if you didn't do it the same way as me, it's okay as long as you get the same answer. We're all going to cross cancel slightly different because we're going to see things in particular first. Okay, so this 5 is going to cancel with this. My goal is to get these ones. So I'm going to cancel this one again. 2 goes into 2 one time, and it goes into 10 5 times. All right, this one's already won, so let's go to this last one. The 5 does not cancel with the 2. It's its only choice. So now I'm down to what is left. Okay, so I have 1 over 1 times 1 over 1 times 1 over 5 times 2 over 6. And when I rewrite it, I see 2 can go into 2 one time and into 6 3 times, which will leave me with 1/15. That should have been your answer, 1/15. All right, so let's go on to multiplication with whole numbers. Okay, so a lot of people have trouble with why can't I multiply whole numbers when I'm doing mixed numbers, okay? I mean, I can do 2 times 3, but when it has a fraction, it's a little bit different. Well, let's go back to our Skittles analogy. I can make 2 bags. I have 2 bags of Skittles, 3 Skittles in a bag, 1 Skittle left over. If I multiply this 2 times this 1, I'm going to get a 3. This is if I have 3 Skittles. But I don't have 3 Skittles. I have 3 Skittles in each one of these 2 bags. Okay, when we're multiplying, it's not like adding at all, where we can just add up our bags and it means the same thing. There's that many Skittles in them. No, when we're multiplying, we need to multiply the individual pieces, or it doesn't really make sense. Okay, so we need to make them improper so I know how many Skittles I have in all. So if 3 Skittles make a bag, I have 2 Skittles plus 1 leftover Skittle, well, then I have 7 Skittles. And in my second one, if I have 5 Skittles make a bag, I have 1 full bag and 1 left over, I have 6 Skittles. Alright, so I need to look to see if there's anything I can cross cancel. Well, 3 goes into 3 one time and into 6 two. Right, so that's what I can cross cancel, and that's going to give me a 14 over 5. Now I'm not done. Because I made them improper fractions, the likelihood of getting an improper fraction out is very high. So I need to be able to turn this into a mixed number very quickly. Remember, 5 Skittles make a bag. I have 14 Skittles. I can make 2 bags with 4 leftover Skittles. So the answer is 2 and 4 bits. Let's try another one. Let's try a different one. 5 and 3/4 times 1 and 1/7. So in this one, I have 23 over 4, and I have 8 over 7. Okay, I can cross cancel my 8 and my 4, and when I multiply across, I'm going to get 46 over 7. Now, this time 7 Skittles make a bag, and I have 46. Well, if you know your multiplication tables, you know I can make 6 bags, which is 42, and that's going to give me 4 left over. All right, let's have you try one. So, let's say I have, let's take it fairly easy. Let's say I have 2 divided by 1/3. Okay, so this is saying I have 2 bricks, and I'm going to divide them into 1/3. So now each of my bricks are divided into 1/3. So how many bricks do I have? Brick pieces. Well, I have 1, 2, 3, 4, 5, 6. I have 6 brick pieces. So how do I get 6? Okay, well, someone a lot smarter than me said, well, if I'm going to divide up my big pieces into smaller pieces, I'm actually going to multiply. I made this into thirds, so now I have 3. Cut it into 3 pieces, and this into 3 pieces. So I'm taking 2 and I'm multiplying it by 3. And they made this idea called keep, change, flip. So we keep the first fraction, we change division to multiplication, so keep, change to multiply, and flip the second fraction. So to do that, what I have to do first is put a 1 under my 2. So now it's 2 over 1 times 3 over 1. Okay, and it's going to give us the 6 we need, because that's how many parts we now have. Where's my microphone? All right, so let's do some more. So let's say I have 1/7 divided by 1/3. Okay, keep, change, flip. I keep the first one. I change division to multiplication, and I flip the second one. And then I just do what I do with multiplication. I just multiply straight across. So 1 times 3 is 3, and 7 times 1 is 7. So I have 3 over 7. So what do I do when I have whole numbers in it? Well, I just combine how I just did division of fractions with what I do when I have whole numbers in my multiplication of fractions. So let's look at this. If I have divided by 1 and 1/7. Okay, so first step, make them improper fractions. So that's going to be 7 over 3 divided by 7/8 over 7. Okay. Second, keep, change, flip. Okay, so keep the first one, change to multiplication, flip the second one, reduce. I don't see any reducing in this one. Nothing cross reduces. So now number 4, multiply. So 7 times 7 is 49 over 24 and turn into a mixed number. Okay, so 24 is how many Skittles make a pack. I have 49. That means I can make 2 with 1 left over. 2 and 1/24. All right, same steps. Number 1, change to improper. So 14/15 over 2 divided by 3/4/5 over 3. And now I have to flip. Okay, so I'm going to do keep, change, flip. I'm going to do some cross canceling with these 5s. 5 goes into 5 one time and into 15 3 times. Now I'm going to multiply across. So 3 times 3 is 9. 2 times 1 is 2. Now I'm going to make into a mixed number. 2 Skittles make a bag. I got 9 Skittles. I can make 4 bags with 1 left over. So 4 1/2. Now let's look at a concept real quick. Because you're going to do a lot of ordering of numbers, so we should understand them. Let's do 2 and 1/2 times 1/7. Oh, I meant to make divide. Divided by 1/7. Okay, so that's one thought. And then let's do the thought of 2/3 divided by 5 and 1/6. Okay, so in this thought, the whole number, okay, this 2 and 1/2 is being divided by a small fraction with no whole number. Okay, so big number, small number. Over here, it's a small fraction being divided by a really big number. So small number, big number. Okay, so let's see what happens. So in this first one, first turn it into improper. Then keep, change, flip. There's nothing to reduce, so I just multiply. And turn into a mixed number. 2 Skittles make a pack of Skittles. 35 Skittles means that I can do 15, 16, 17. So it's going to be, yeah, 1/2. Ah, sorry, I hit the button on my pen. 1/2. 17 and 1/2. Okay, so when I divide a small number into a big number, I get a really big number as the answer. It makes sense because it's saying I have 2.5 bricks and I'm going to cut each brick into 1/7 of a piece. So I should have tons of little tiny bricks when I'm done. So let's see what happens if I take a small fraction of something and I cut it into big fractions of something. Kind of a hard concept to visualize, but let's see what happens when I do it. Okay, so the first thing is I make my fractions improper. That's 31 over 6. Then I keep, change, flip. Reduce. 3 goes in there 2 times. 3 goes in there once. Then I multiply. 4 over 31. 31's prime. I can't go down any further. So we're done and the answer is 4/31. So when I take a big number and divide it into a small number, I'm going to get a small fraction. Same thing with whole numbers. If I take 10 and I divide 2 into it, I'm going to get 5. But if I take 2 and I divide 10 into it, I'm going to get 1/5. Same concept. We have to keep this number sense in our brain because there's a lot of questions on the T's that just require some number sense. So now let's have you do some, okay? So I want you to do 5 and 1. Oh, let me put it back on my pen. 5 1/2 divided by 1/3. And let's do 2/3 divided by 3 1/7. So go ahead, pause and try those two. You should already have in mind which one's going to yield a big answer and which one's going to yield a small answer. So you know if you did it wrong. Okay? Pause the tape when you're done working it out. Start it back up again and we'll see if we got the same answer. Alright, for the first one, it should be 11 over 2 times 3 over 1. Nothing cancels. 33 over 2, which means 15, 16 and 1/2. Alright, so this should have been your answer. Second one is 2 over 3 times 21, 22 over 7. This will reduce with this. 2 can go into 2 one time and into 22 11 times. So I have 7 over 33. Big number, small number. All right, so that's all for multiplication and division of fractions. Next, we're going to be talking about decimals, so I'll see you in a little bit.